Hey there, and welcome. Today, we're going to tackle a topic that, well, let's be honest, it might bring back some not-so-great memories from high school chemistry. We're talking acids, bases, and the pH scale. But hang in there with me. I promise. I'm going to show you a few super simple tricks that will make all of this click and actually stick for good. I mean, have you ever really thought about it? Why does a lemon make your face scrunch up like that? And why does a bar of soap feel so slick and slippery in your hands? These aren't just random little facts of life. Nope, this is chemistry in action, and the answers are hiding in the very concepts we're about to break down.
Here's the thing. I'm willing to bet that most of us have been in this boat. You cram for a chemistry test. You memorize that acids are sour, bases are bitter. You ace the test, and then what happens? A week later, poof, it's just gone. You know why? It's because we learn the facts without the logic. We're missing the why that holds it all together.
And that's exactly why this subject can feel so darn tough. It feels like you're just trying to stuff a giant random pile of facts into your brain. But what if I told you there's a much better way? A way to build a simple mental framework where everything just clicks.
This right here, this analogy just hits the nail on the head. It's like someone hands you a recipe and tells you to add baking soda, but they never explain that it's the key ingredient that makes the cake fluffy and delicious. Without that why, the instruction is just a random rule, and it's so easy to forget. Well, today we're finally going to learn the why.
So let's dive into our first simple framework. I want you to stop thinking of this as boring memorization. Instead, think of it like you're cracking a code. Because I guarantee, once you see this pattern, you won't be able to unsee it.
Okay, for acids, the code is super simple. SAL. SAL. First up, S is for sour. Easy enough, right? Think of lemons, vinegar, that sharp, tangy taste. That's the acid working its magic. Next, A is for aqua, which just means water. And listen, this part is absolutely crucial. Acids only show their true colors when they're dissolved in water. And finally, L is for litmus. Acids turn blue litmus paper red. A good way to remember this is red for danger, since strong acids can be pretty corrosive.
Let's just zero in on that aqua piece for a second, because this is a big one. Take a look at this. Dry hydrogen chloride, or HCl gas, is basically powerless. It doesn't act like an acid at all. But the second you dissolve it in water, bam! It can suddenly conduct electricity and shows all those classic acidic properties. This is a favorite exam question, and now you know the secret. Water is the key. It's what unlocks an acid's power. Now, what about bases? Well, their code is just as straightforward. Slippery, bitter, blue. Bases feel slippery to the touch. Soap is the perfect example here. They tend to have a bitter taste, kind of like baking soda. And they do the exact opposite of acids with litmus paper. They turn red litmus blue. Just think blue for base. Simple. So what happens when acids actually react with other stuff? Well, check this out. This slide reveals a really powerful pattern. Look closely. When an acid reacts with a metal, or a metal carbonate, or even a base, what's the one product they almost always make? You see it? Salt. Recognizing this one single pattern is so much easier than trying to memorize 3 different equations.
All right, let's keep going and move on to our next memory hack. This one is for remembering chemical indicators. You know, that part of chemistry that feels like you're just trying to memorize a random list of colors? We're going to simplify all that by turning it into a little color game.
I want you to just picture a traffic light in your head, okay? The red zone is for acids. Red means stop, danger, right? The middle, yellow zone is for neutral things, like pure water. And the green/blue zone, that's for bases. Green means go, safe. If you just mentally organize the colors this way, you've got a simple map for where everything belongs.
Now let's put this into practice with a few common indicators. So litmus fits our model perfectly. It turns red in acid and blue in base. Check. Methyl orange also fits. It's red in the acid zone and yellow in the neutral or base zone. And then you get an interesting one like phenolphthalein. It's totally colorless in acids, but turns this amazing, vibrant pink in bases. And here's a little pro tip for you. If you're ever writing an exam or a lab report, phenolphthalein is a fantastic indicator to talk about. You know why? Because that color change is so dramatic. I mean, going from nothing to bright pink, that's huge. Using a phrase like, "it provides a clear visual distinction," just shows you have a deeper level of understanding.
All right, let's tackle our last big concept, the pH scale. I know this can seem really abstract and confusing with all the numbers, so let's reframe it.
Don't think of it as a boring scale. From now on, I want you to think of it as a power meter, just like you'd see in a video game.
So this power meter runs from 0 all the way to 14. Down at the very low end, we're talking 0 to 2, you've got crazy powerful acids like the stuff in your stomach. Then, right in the dead center, at a pH of 7, you have perfect neutrality. Think pure water. As you climb up the scale, you get into the bases. Soap is around a 10, and you can go all the way up to super strong bases like bleach, which is way up there at 13.
I just want you to focus on this number for a quick second. 7. This number is your anchor. It is your home base. It's the perfect point of balance. Everything else on the pH scale, whether it's an acid or a base, is measured by how far away it is from this neutral center. It's the baseline for the whole system.
Okay, now listen up, because this is the single most important rule to remember, and it's the one part that trips everybody up. The scale is inverse. That means a lower pH number means a stronger acid. I know, it feels backwards, right? But think about it like a countdown to something really powerful. The lower the number gets, the more intense the acid is. So a pH of 1 is way, way stronger than a pH of 6.
So, how do we take all of this and make sure it actually sticks around for good? Well, it's time for a quick action plan.
First, let's just do a super quick recap of the 3 mental models we've built. We've got our simple codes for acids and bases, SOL and slippery bitter blue. We have the traffic light method for remembering all those indicator colors, and we have our new way of thinking about pH as an inverse power scale. Lower number equals stronger acid. These are your new tools.
Now, to really lock this stuff in, I've got a little homework for you. Don't just watch this. Actually do something with it. Sometime today, grab a piece of paper and sketch out that traffic light chart with the right colors. Write out those key reaction patterns a few times until that salt pattern just pops out at you. And then, for fun, walk around your house and try to guess the pH of stuff. Is the vinegar a 2 or a 3? Is the baking soda an 8 or a 9? This is the kind of active practice that makes you a master.
Because at the end of the day, chemistry isn't just another subject you have to pass in school. It's literally the language that explains the world all around you, from the food you eat to the soap you use. The real goal isn't just to memorize facts, it's to see the patterns underneath it all, to really understand. So the only question left is, what will you choose to understand next?